Hello. Hi, everyone.
Hello, ma'am.
Hello, Prasanthi.
Good evening, all.
Good evening, ma'am.
For yesterday's session, recorded session. Hi, Kalyan.
Yes,
Hi, ma'am.
Have you started demo sessions first?
Yes, I do started demonstrations.
Okay. So, do you have any doubts in that? Have you understood the
Uh,
system Verilog architecture and what are the limitations of Verilog HDL and the best features of system Verilog and
yeah,
system on chip
I haven't
protocols?
gone all of
Mhm.
them, but as of now, I didn't have any doubts.
Okay, fine. So whenever you have doubt, just ask in the session. Okay. So today we are going to start with remaining concepts. In the last session, we have completed till data types and also arrays, right? Different types of arrays. Have you worked on dynamic array, static array, and associative array? I already shared the reference codes also in group itself. Have you tried the queues assignment? I have shared. Today I will share the queue assignment and mailbox assignment semaphore. Today we are going to discuss the mailbox semaphore concepts. Okay. Let me know if you have any doubts in arrays and also queues.
Uh, Prasanthi, like I have done the arrays assignment. In that, there was a question to use array methods of for to get the first and last element like that. But in EDF playground, it is telling that last method is not there in the system Verilog.
Last method,
It's not defined for the data type of.
no, we have. We already worked with associative array, right?
For the dynamic array.
Okay, wait. I have explained associative also. Others, any doubts? Are you practicing? From today, we will have alternate days only, not regularly. We discussed this example yesterday. In this last is there here we use last 38
Mm.
line. Is this not printing?
So I have used for the dynamic array. Will it not? It will be
We
the
don't
same method in the dynamic array, or
know. Dynamic
actually
array.
in the
Mm,
last question of the assignment. Just a minute.
see here, last one is printing 20 of array. So it's a 20.
Okay.
Last one.
So actually, it was telling code for array built-in method. So it was not telling either associative or static. So I have used dynamic array. So for that, it was not. It is telling last is not defined for this data type.
Okay. For dynamic array, we have only these methods, only size and array we can check, delete. That's
Okay.
it.
Yeah.
We don't have first, last. This syntax is different, associative array is different.
Yeah. Yeah.
Okay.
Okay.
Others, any doubts from your side? Next, queues or completed casting we will discuss in OOPS concept. Okay, program block also we will discuss in OOPS. And coming to fork join, today we will discuss on fork join. So can you tell me about what is mean by join? You already used in Verilog HTL, right? What is the difference between begin and fork join? First,
Beginning.
In the beginning,
mm,
Ma'am, TP components are running at concurrent. We can achieve concurrency manner through fork join.
Ma'am, begin and serial execution, fork join, parallel execution.
okay. In Verilog HDL, how many types of fork joins are there? In Verilog, we have only one type of fork join, right? So in Verilog,
only
there are
one.
sequential execution statements and parallel execution statements. A begin end is nothing but sequential. That means whatever the data we are writing within the begin end, whatever the number of statements we are writing in begin end, all these statements will execute in a serial execution. And whatever the statements we write in a fork join, all the statements execute parallelly. And also we call it as a threads. Okay, so we already seen lot of examples for begin end and fork join. So I will give you some example and tell me what is the answer. Begin. Okay, this is for begin and end. And coming to fork join. So what is the output for first one and second one? Can you tell the answer? For begin end, if you consider the begin end, at what time what statements are executed, and fork join, at what time what statements are executed. The difference between serial execution and parallel execution.
So the first in the begin end, first statement will execute at 5 time minutes, and then second statement will work complete at 7 time units. So likewise, the time will add in the begin end, and it is a blocking also. But in the fork join, it first like at 2 nanoseconds, second statement will work. At 5 nanoseconds, for first statement will start, and third statement will work on 7 nanoseconds. Fourth one will start on 10 nanoseconds.
Okay, so for here, others, can you tell answers at what time what statements are executing? Ranjit, Manoj, Rakshita, Shweta. Others, Navin, Kalyan. First hash 5, 5 plus 2, 7, 7 plus 7, 14, 14 plus 10, 24. That's it. And here, first has to statement will be printed. Next, hash 5, next hash 7, next hash 10. So like this, the statements will be printed. So that is what the difference between parallel execution and serial execution. Clear, everyone? So whenever we use fork join, all the statements will be printed. Whatever the lesson statement, fork join means all statements will be printed. But in System Verilog, in same fork join, we have 3 classification: fork join any, fork join none, fork join all. Okay, that means fork join any means any one of the statement will be printed within a fork, and remaining all threads will come out of the fork. Okay, fork any means which one the statement will be printed. What is that any statement? What is that any statement?
So hash 2 will complete its job and then will come out all.
Okay, hash 2, because hash 2 is the less delay. Obviously, less delay statements will be printed first, right? So that statement will execute and the loop will come out. After coming out, if you want to print remaining statements, you can print, or else you can break the loop. Okay, simply we can write like a disable fork, or you can print all the statements after coming the out also. Okay, fork join any means any one of the statement will be printed within the fork. Fork join none means no statement will be printed. All statement comes out of the loop. Okay. All means fork join all in the sense all the statements will be printed within the loop. Okay. So we will see the examples. And see here. This is what the structural diagram for fork join all. That means this is one thread. Parallel thread 1, parallel thread 2, parallel thread 3. Within a threads also, we will, if you want to write multiple begin and statements, sequential execution statements, we can write. Fork join any means any one of the statement. If you see here, for any OR gate is preferred. That means least execution time statement will be printed. Remaining all come out of the loop. Here AND statement. That means all statements will be printed. Join none means if you see here, the execution of fork automatically it comes out of the loop. These statements will not execute within a fork join. It comes out of the loop. After coming out of the loop, if you want to print, you can print, or else you can avoid. Okay. So mostly, what are the maybe you may get the doubt why we need to use like this. Okay, what are the applications in System Verilog only? Everything we are writing within the components, right? There are different components like generator, driver, monitor, scoreboard. Okay, where we are running all these 4 blocks within the environment. Environment is the top level. In the environment, we run all these 4 components using the instances. Okay, how we are running those 4 instances? Through the fork join concept only, because fork join is a parallel execution. So through the fork join only we will execute. Environment. Okay, here is the environment. In this environment, we have included all subcomponents: generator, driver, monitor, scoreboard, and transaction. So if you see here, 16th to 19th, we have created the instances for 4 components, and also within a task we created, that means allocating the memory. And if you see the start, whatever the generator block, the start method, main method is there, that block, and driver main method, monitor main method, scoreboard main method, everything we need to run from the environment only. Okay, so here we are using fork join. Within the fork join, we are writing all this. That means all the statements will execute parallelly, and also we are printing all the statements at a output. Okay. If you want to print only generator, then you can use any, or you can use none or all. Okay, based on the delays. Mostly here we don't write the delays, but whenever we are writing the local delays in the generator driver, based on that also it will be working. Okay, so this is how we will connect the fork join concept in system verilog test bench. So we will see the examples now. Okay, what are the different types of examples? So if you see first one, fork join all. Okay, you can tell the answer directly. So can you explain here what is this fork join? Okay, what is the output for this? At what time which statement is executed?
So first display statement will work. Will first is 5 at 5 nanoseconds, 5
Okay.
time units. Then uh, then at 10 nanoseconds, and before fork also that will be at 10 also. Then so those two will print simultaneously, and then 20 nanoseconds.
Okay, first this 10 nanosecond statement is printing up.
I mean first that 5 nanosecond
Which 5 nanoseconds?
in
The
fork
last
join.
display statement will be printed first. So since we have a time unit before the fork, the last display statement, that 5 is added with this 10.
Okay.
So dollar time, that will be 5, but the display statement, like, it will be displayed at 15 nanosecond.
Okay. Okay. First, which statement will
hash
be
5,
displayed?
this
5 or 10? This or this?
5.
5.
Five.
Where it is 5? Within a
10.
fork or within a begin end?
Ma'am, first
Here all
beginning
beginnings
will
will
be
start at 0th nanosecond.
Okay. All begin end statements
So
start at 0. Okay.
then first hash 5 will be executed,
Hash
and
5, where it is? Okay, okay, tell your answer first. Okay, hash 5 will be printed first. Okay. Next,
next hash 10 and hash 20. Okay.
If begin and end is starting its execution at 0 nanosecond, that display statement will be executed first, and then it enters the fork join.
just wait. He is telling some other answer, right? Let me clear from him side first. Yeah, tell your answer. Hash 5 first, then
Hash 5 display statement, ma'am.
hash. How
First
much?
hash 5, after that hash 10, after that
Um,
hash 20.
yeah. Okay.
After all that, display statement will be
Which
out the
display?
main port
At what time?
at 20
20. Okay.
nanoseconds.
Okay. Next.
I don't know about that, ma'am. Hash 40, I don't know the percent.
Okay. Fine. Fine. Others answers, girls. Others, girls, someone are telling. Okay, see, first of all, let me explain. From this answer, this is totally wrong. So if you see here, first initial begin is there. Okay. Initial begin means all statements will execute sequentially, right? So this is one statement. And this fork join will consider as a second statement. And this display can be considered as third statement. Okay. Even if you write multiple number of statements within a begin and fork join and fork join, within begin, first this fork join is considered, then this fork join will execute, and then this fork join. All fork joins will execute sequentially. And also within a fork join, there are few statements at #2, some is printing #5, it is printing #3, it is printing. So like that we have different statements. Okay. So in begin, first it is executing this fork join, right? Within a fork join, all three statements will execute, and then it will come out of loop. Then this fork join will execute, and within the whatever the delays are there, again here the delays will execute now. Okay, then this fork join also complete, and then third fork join, this whatever the third fork join is there, that will be printed. Okay, that is what the process. So suppose first fork join is executing at 10 time units. The delay of first fork join is 10 time delay, and second fork join delay is a 20 time delay. Okay. Now this 10 time delay will be added to this 3. 10 plus 3, 13. And this 5 will be executed with this delay. That means 10 plus 5, 15. And this 10 will be executed with #2, 12 delay. Like that the delays will be executed, and whatever this main final delay is, that delay will be printed with this also. This 20 delay and previous delay will be added to the within fork join delays also. Okay. Now I think everyone got clarity. Now you can answer. What will be the output for this?
Is it like
First
10,
is 10
5,
nanoseconds.
20, 40?
Did you understood everyone whatever I told now?
Yes.
Okay.
Yes, ma'am.
Ma'am, I
Ten.
have a doubt here. Like, inside begin end, we have fork join. In that fork join, the execution will be parallel only, right? Because
Yes.
fork join is parallel. Okay, got it.
Yes. Complete your question.
Oh, yeah, ma'am. I understood.
Okay. Okay, yeah. Now tell your answer.
Is it like 10, 5, 10, 20, 40?
10, 5.
5, 10.
Observe clearly.
15.
10, 15.
15 is there.
Okay.
10, 15, 20,
20.
30,
Okay.
40.
30. Okay.
30, and 50.
30. Next. 50. Yeah.
50. 50, yes.
50.
Yeah.
50. How?
That's 40 is
40.
there, no? That, okay, that is a, and
Ma'am, I
10 is
think
up.
this should be 80.
80.
No, 40.
40.
So last statement is of at the 40.
This
Uh,
statement when it will be printed, this outside main fork.
Ma'am, 80. 80, I think.
After
This
30
display
will print.
statement.
30.
30.
After 30.
Yeah, 30, then 40, then 70. Oh, yeah.
30. And if there is any display
Okay.
after 40, then what time it will be printed? If is
70.
if there is any display statement here, at what time it will be printed?
70.
How 20?
70. 70.
70.
70. At 70 time units, remaining statement will be printed. Okay. Everyone understood fork join concept?
How the 70 is coming, Prasanti, just
30 plus 40, 70. Here it is 30. This display statement is printing at 30. 30 plus this 40, then next statement will be printed at 70. If it is there.
okay. But that 40 is at after display, no? That 40.
Mhm. After display, where I written this line, I drawn after 40 only.
Ma'am, here I have a doubt. Like
Mhm.
for inside fork join, we have the 30 time instant. After fork join, we have the display statement, right? Still, it will consider that 30 time instant.
Yes. Here 30. At same time, the display will be printed. Suppose if the display statement have 10 delay here, hash 10. Then this 30 and this hash 10 will be added. Then 40. 14 plus next to 40, 80. 80 time units. If any statement is there here after 40, that will be printed.
Okay, ma'am.
Okay. We'll do the execution. Program main 10. Okay. Okay. Now check the answer. Is it correct or not? So 10 time units, 15, this 5 delay is executing at 15 time units, 10 plus 5, 15, and then 10, 10 plus 10, 20, 10 plus 20, 30, outside the main fork executing at 30 time units. If there is any statement here after 40, suppose I'm copying this same display statement and print after 40. See, 40 delay statement is printing at 70 time units. Okay, clear everyone about fork join concept? Any doubts? Guys, any doubts? Okay, next next one, fork join any. Suppose same example, can you tell me what will be the output for fork join any? Same I am considering, but in place of join, I need to put like this, any. So what will be the output?
First 10 time instant will be executed, then 15 will be executed, then it will come out, and at 15 the display statement outside the main fork will be executed. After that it will be added to 40, that means 55 the other display statement will be executed.
Okay. Remaining these two statements, will it not be
Will be
printed?
skipped. It will be skipped, ma'am.
Okay. If you want to print these two also, then what we need to do?
We need to keep fork join all, then all statements will be printed.
Without using fork join all, how can we print?
Without using fork join all, no idea.
Okay. So let me check that answer. Guys, did everyone understood? See, first before fork join 10 is printing, and then 5 any means one, any one will be added, any one thread. Okay, that too least delay, whatever the least delay thread is there, that will be printed, and fork join will come outside the loop. So at what time it is coming outside the loop? At 15 time unit. Before it came at 30 time units, right? A current delay. Same here at 15 time units, it is coming out of the loop. And next two statements are also will be printed automatically. We no need to do anything. Automatically these two statements will be printed. If we want to remove, if you don't want to print these two statements, then what we need to do means we can disable the fork. Okay. Disable fork. Or else if you want to print all, you can wait for the fork to print all. Syntax. Semicolon.
Ma'am, here I have doubt. But fork join any, like by default it should display only one statement, right? Then why it is printing 20 and 10 by default?
See, one only it is printing, right? Within the fork we need to check, not outside the fork.
Okay.
Within the fork it is printing one only. I just use that disable fork. So remaining two also not printing automatically. It is coming outside the main fork and printing the 40 delay statement. And these 20 delay statement and 10 delay statements are not printing. Okay, everyone understood? Any doubts in this? Any doubts? Okay, suppose if we use fork join none, then what will be the output? Fork join none.
Then ma'am, 10,
Hmm.
first 10, and
Hmm.
then it will not wait to complete within fork join. It will come outside and print for 50, and also inside the fork it will be the same, like 15, 20, 30.
Okay. Others, your answers? See, first 10 begin and block executed. Automatically it comes outside the main fork. That means within the fork join, no statement is printing. Okay, after coming the outside, it just printing the remaining threads, leftover threads, and then coming outside the loop. If you don't want to print these threads, okay, and then you can just disable the fork like this. All these are very small concepts, but we need to understand clearly. Then only we can apply in a test bench level, right? If you want to apply here in a test bench hierarchy, first you need to understand the concept clearly. Okay. So see,
Ma'am, I
10
have a doubt.
and 50. Yeah.
Ma'am, I have a doubt. The fork will not means it will fork for none. It will not wait for to complete inside the if to complete the fork join, but parallelly it will print inside the fork join also, right? Ma
Okay.
The means I am saying means in fork join none, like
Hmm.
it will print 50, it will print 50 at 50th trade, but it will parallelly, it will print 15, 20, 30 within.
These three. Oh, yes, it
Yeah.
will outside the loop. But before it is printed, right here, I use the disable fork. So that's why it is not printing. If I put column here, I comment there, you will see these three before I have shown. But outside the loop, see, outside the fork, these three will be printed.
Okay, okay, fine.
Okay. So
Yeah.
that is what about fork join any, fork join none. Like that, we have fork join all. That means all forks will be printed within the loop. Okay. So run. Fork join all.
I think we don't need underscore, right, ma'am? Beside join. Join. Oh,
We need to put underscore, but why it's not printing? Fork join and all both are same syntax. So join and all both the same syntax. No need to write particularly all. Just join means same to all. Just however we see first statement same. Okay. So everyone got clarity till here? Any doubts? Let me know if you have any doubts. Now I'm writing, suppose now tell me what will be the output.
So inside fork join also there is a three begin and right. Then these three begin and run sequentially, but so first will be 10 nanosecond before fork time, that is there, and then first begin inside the fork join, first begin and will uh, will be there. Uh,
Mhm.
Yeah, so uh,
So
First
in
is before
first,
time at hash 10. After
okay,
that,
question.
at hash 15, uh, start begin and in fork join. After that, uh, in second beginning, hash 10 display will be printed. After that, uh, two displays are going to be printed. Fork join in first in first beginning in fork join, hash 5 display statement will be printed. After that,
Okay.
hash 20 display statement in first fork join and first beginning, and in second beginning hash 10 second display statement
You're
going to be printed.
combining, wait, you're combining both beginnings. You
Ma'am,
can,
can I tell?
yes.
Ma'am, can I try? The first will be at 10. Then for first for beginning it will be 30. Then 30. Then 35, and then again 35. Then 45, and for second beginner it will be 20. 20, then 30, then 30, and then sorry, 20, 10, 10. It will add all 20, then 30, then 50, and in third one it will be 15, and the last one will is print at 90.
This one, 19th line.
90, I think, because the it will come out at 50th time maximum when all will complete. So 50 plus 40, it will be 90.
19th line.
19th line display. Oh, you are disabling fog.
This statement. At what time it will be printed?
Join. It will be print at 50th, 50th line. 50th, yeah,
Okay.
50 time unit, and if you and then 90.
90.
Yeah, 50 plus 40, 90. Not 15, it's 50, 50.
This statement will be printed at 50, 50,
Yeah,
no?
yeah, right.
Okay.
Then at 90 time unit.
40 plus 50, 90.
Yeah.
Okay, good. Any doubts or any mistakes from here? Others? Can you cross check once? Kalyan, is it clear for you?
No, ma'am. I feel like we're supposed to add as 10 nanoseconds for each fork joint.
Each fork join. How many fork joints
I
are
mean, like
there?
each fork, each beginner name. Sorry,
Okay.
for each beginner black
Do we
block.
not you added
Uh,
here? Here and here and here, three
yeah,
beginners.
we do. Yeah, we do added as 10 nanoseconds for each and everything. But
You're thinking before example. In that case, we have added to each beginning. You're telling that to add within the beginning statements also, right? For all three statements within the beginning, and here three statements you need to add hash 10, like that you are telling, right?
yes, ma'am.
How can you add that? Normally, beginning statement, how it will be printed? It will add local delays only, right?
Yes, it will add. But we already gave as 10 delay in the start, right? So it's supposed
Okay,
to
tell me
add that
your
from.
answer. Okay, tell me your answer. What is your answer? Hash 10 first and then
Yeah, hash 30.
okay.
Yeah, hash like supposed to add 10 for each and everything. Like hash 15, hash 20.
Mm-hmm. Okay.
And then again hash 20, hash 20, hash 30.
Okay.
Yeah, hash 15 and hash 50, 50.
Hash 15 and hash 50. How did you got hash 50 here?
There is a like hash 40 delay after the
At what time this statement is printing? 19th.
it's supposed to print at 40 nanoseconds.
40. How? How 40? Which one is correct? Others, can you tell me? Actually, I will tell you how you understood. This is wrong. Whatever you said, it's wrong. You understood like you are adding this 10, whatever the fifth line hash 10 delay is there, you are adding to each one, begin end. You are thinking like these all are in fork join. Okay. These all are not in fork join. For fork join, okay, this begin end is one thread and 12 to 15th, whatever the begin end is there, that is thread 2. And this begin end is thread 3. Okay. So for 3 beginnings, you need to add hash 10 only for first statements only, not for all statements. For 3 threads, 3 times you need to add the delay. Okay. But within this, within the begin end block, there are 3 more. These are not threads to the begin end. These are sequential execution statements. So first hash 20 will be printed. Whatever the thread added to the delay added to 20, that will be printed. 20 plus 10, 30. 30 plus 5, 35. 35 plus 10, 45. That is how the execution, sequential execution. Like that, this begin and also execute sequentially one by one. Like this. 20, the first delay 10 will be added to here. Remaining two statements are sequential to begin end. And here only one statement is the directly, that is a thread. You can add this 10 delay to 15 here. Okay. So at what time this statement will be printed? That is what the question. Whether it is printed at 50 time units, obviously it is printed at 50 time units, because if it is a 15, this thread will be printed uh, before. So 50 time units, the statement will be printed here, and 50 plus 40, last statement will be printed. Okay, we'll do execution and check. What is the error? Fourth line. Okay, right side. check here. Better wait. For no more confusion. See, here beginning 1 is a one fork, 2 is another fork, 3 is another fork. Within the delays, compared to these three, third one is least delay. So this fork, this thread, not fork, this thread is printing first, beginning. Okay. And which one is the least delay? Obviously this first, because here #5 delay is there, that is printing. Second one 10 is printing. Okay, because it is considering first statement within the begin end. So compared to 20, here 10 is least, right? So that's why second statement is printing. Begin end 2 is printing here. Okay, I'm just reversing both, then check which will be printed. 10 I am putting here, 20 I am putting here. And the two here we have 20s, 20s 2 are there. Let's see. So as I mentioned, 21st, 10 first here, it's a least delay. So begin 1 is printing before begin 2 is printed, because that for that we put less delay. And then next comparing both. Here 10, again 20, but here this delay is least delay. Okay, so that 5 is printing. Wait, we will change these delays also. Begin time at #10 at #5 10 20 10 20. Okay. Okay, so same. #10 printed first, #5 printed first, and then second one #20 printed, and then first one #10th one. Two delays are there, right? That's why. And #20, #1, 10th one, and in second one 10, and last one 20. So at the time 60 time units outside the main fork, and 40 delay 100. This execution is correct. Whatever we have written first one is correct, but inside the simulation now it is checking for every one. Actually these statements will execute sequentially, but internal simulator is considering based on the delays. Okay, based on the delays it is printing, which is first and second. Okay, so now we will get order of delays. I will share the code. Afterwards, everyone check and try to understand. Any doubt still here?
If there will be matching delays, like both of them are at 2020 in both of the begin end statements, which one would be executing first?
For matching delays also it is comparing. First, which one is 20? Suppose here it is a 20 first. Okay, so it is printing and compare it to 10 here, both 110 and here 110. So first one is a first 10 is in begin and first. So begin and first is printing and then begin and 2 is printing. So if you see here, begin and first 10 is printed and begin and 2 10 is printed and then begin and 2 20 is printed. Within that it is comparing the delays and which fork having first. Based on that it is printing.
Okay.
Okay. Any doubts, others?
If first statement in the first beginning it will be 20, then it will start. I mean, how it will start? Any of that will start.
What?
If in the first beginning, first statement will be 20. Like if you make it instead of 10,
Okay.
if you make it 20.
Before we have seen, right, instead of 20, if I am putting here this one having 20 and also this one having 20. Okay, so within these one to both will parallelly both will printed one on one. Or else if I put 20 here and 10 here, obviously second begin to. Suppose I'm putting 10 here, we'll see both examples. Before this statement printed, right? First. Now begin 2 will be printed. See. Begin and 2. Okay. But if both having 20, 20, then both will print at a time. A little difference will be there, one after one. Okay, if both are having same delays, then whatever the before delay is there, it is checking that. But in that case, it should print #5, right? If we check for delay. (30-time units, 10 and 20-time units).
First it is printing the first statement of both. Then it is coming to
what?
I mean, it is printing at 13 nanosecond for first begin and also, and then for second begin and also. Right?
Wait 1 second. 20 and here 20. Now it's printing correct. Yes. Now it's printing correct. This statement is printing and also this statement, both are printing parallelly. Before I didn't change here, right? So that's why it looked like a 10, but both 20s are printing first. If we put one delay small, suppose 10, then obviously second one will be printed and then it will go to first big end. Okay, here I need to change this 10 in the display statement. See, 10 it is printing first and then it is going to first one, then first 20 is printing. Further, these are adding delays. According to those delays, printing at the output. Okay, clear everyone? Any doubts? So this is what
beginning statement. There is like a 5 delay, and also in third beginning statement also having 5 delay. So like why the third one it is printing first and in the later on that first one is printing like with 5 delay. Like wait second.
Just check from your side. If I leave like this, you will ask questions for next hour also. Just check from your side. If you don't understand, let me, you can ask tomorrow. Okay. Any other queries other than that? Okay, fine. And next thing is a wait fork. So if you see here, wait fork in the sense of in join any, only one statement will be executed within the fork join and remaining all are coming out. Okay. So whenever it is outside the main fork, if it is not printing the value, then we need to wait until to print all the values. Okay. Then only it will come outside the loop. After outside the main fork, it will print remaining values also. Just check with the wait fork and also disable fork. Okay. So till here, fork join concept is completed. Okay. Next, semaphore concept. Most important concept, but mostly we don't use anywhere. Very rare cases. Mailbox concept we use in every test bench. Okay. Now we'll look into semaphore concept. So what is meant by semaphore? What is mean by semaphore? Okay, better I will explain mailbox first, then you can understand semaphore easily. Okay, first let me explain mailbox. Can you tell me what is mean by mailbox? We already discussed lot of times.
The means of communication between the generator and driver, I mean between the test bench components, like monitor to scoreboard. So it is used for the communication between the test bench components.
Okay. Okay. So why do we use only mailbox? We have queues to store the data temporarily. We have arrays to store the data temporarily, and also we have FIFOs. But why do we use mailbox? Why don't we use queue?
Mailbox providing blocking nature between generator and driver.
Blocking nature. Okay. What is the difference between blocking and non-blocking in terms of mailbox? What is the difference between blocking and non-blocking? Okay, see.
I think is to generate either combinational or sequential logics.
No. Okay, see, we'll discuss. So in test bench architecture, we have 4 different blocks, right? Generator to driver, driver to DUT. Driver to DUT, we will connect via interface, and here is the DUT. And after doing the functionality, so from generator to driver, we will pass the input test vectors. Okay, suppose your the design is related to A is equal to B plus C. So here B and C are the inputs. To do this functionality, okay, B and C we need to pass from the test. Okay, so here in generator we will generate the random values. Suppose B is equal to 10, C is equal to 20. Like this we are generating here. These values we will send to the driver via mailbox, right? Via mailbox. So this is what mailbox communicator between generator to driver. And same this B equal to 10, C equal to 20, these values are getting here, and we are sending those values to DUT via interface and also virtual interface. Okay, now whatever the test vectors got here, 10 and C equal to 20, A is doing that functionality and A is getting assigned that value 30. Okay, so that values we need to print at the output console. But how we can print, we need to get that values to the monitor. So this is what the monitor block. from the monitor. In Verilog HDL, we cannot check the theoretical values and practical values. Manually, we can check, but through the coding, we cannot check, right? But in scoreboard, in system Verilog, we can write the golden reference logic. Okay, golden reference values we can generate, and we can compare the actual value and also expected value. Okay, so this is what the scoreboard in the sense, here we are getting A is equal to 30. Manually, we will do the calculations here. We will check whether A is equal to 30 correct or wrong. Okay, how we are sending this data from mailbox to here, from monitor to scoreboard? Through the mailbox only. Okay, so here and here, both cases we are using the mailbox. Here we use the put method. From generator to monitor, if you want to send the data, we use put method. From monitor of mailbox, from mailbox to driver, if you want to get that data, we use the get method. Okay, so you may get the doubt now, why we are using mailbox? Why can't we send directly this data from generator to driver and also monitor to scoreboard? Okay, you already know generator works at a different frequencies and also driver works at a different frequencies, right? Here not only B is equal to 10, C is equal to 20. We will check with a lot of scenarios, right? We need to check with every corner case scenario. If it is a 4-bit size, means how many combinations will be there? 2 power 4. Total 16 number of scenarios we need to generate. Okay, so 16 number of scenarios we need to check. In verification, one of the major thing is a coverage. Okay, whenever we get the coverage as 100%, then only our verification engineer task is done. So when do we get 100% coverage? Whenever we generate all test vectors, all possible scenarios, whenever all tests are passed, then only we will get the coverage report as 100%. Okay, so we cannot skip any one of the scenario. We need to check all corner case scenarios, even in exponential values, negative values, positive values, all. Okay, so here suppose 16 number of transactions are generating from the generator. All these 16 number of transactions should be sent to the driver. Okay, but maybe generator works at some high level frequency and driver works at a low frequency. Okay, generator is generating 16 number of transactions within 5 seconds. Just in 5 seconds, it is generating all 16 transactions and sending to the driver directly. Okay, but here driver cannot utilize all the transaction. It cannot get all the transactions within 5 seconds, because here driver need to get the data and also it should send to the interface need to access the data one by one. It should send the data. Maybe little different, just a little simulation speed difference will be there. Okay, so in that case, if generator is sending all 16 transactions in 5 seconds, but the driver is taking every transaction 1 second to transfer to the interface. Okay, so then within 5 seconds, how many transactions the driver can send? Only 5 number of transactions only. Within 5 seconds, only 5 different scenarios or 5 number of transactions only it can send, right? So after these 5 seconds, okay, first 16 number of transactions are completed. Generator now again generating another 16 transactions in next 5 seconds. Okay, but still driver didn't pass all those 16 transactions. Driver sent only 5 transactions till now. Then what about remaining transactions? If again it initiating the transfer, the driver is going to lose the data, right? It is not sending that all 16 number of transactions. It is not verifying all particular scenarios. So there will be a loss of data. We are not checking everything properly. Okay, so to avoid these delays, mismatches, okay, to make the synchronization, we are not making any synchronization here, but whatever the 16 number of scenarios are generated here from generator, those we are putting into the mailbox. Okay, first transaction, second transaction, third, fourth, fifth, till 16 transactions we are putting here, and driver will access one by one. first transaction it will be getting from the mailbox and sending to the DUT. After completing that, second transaction, third transaction, fourth transaction, slowly based on its time frequency, slowly the driver is getting one by one. Okay, so generator, it can generate any number of transactions and put into the mailbox. Mailbox is like a temporary storage element. Okay, so it is just communicated between the generator to driver, just like a temporary storage component or element. Did you got understand everyone now? What is the use of mailbox? That is what conceptual wise, but we need to write the program for mailbox. Okay, clear till here? Any doubts?
Yes, ma'am. Clear.
Okay, fine. Next, so in mailbox, we have two types. One is a generic mailbox, one is a parameterized mailbox. In generic mailbox, if you see the syntax, just we write the mailbox and name of the mailbox. In parameterized mailbox, we write mailbox and hash type. You already know what is meant by parameter, right? We declare the constant values to the particular variables. So here hash type in the sense data type. Data type is a parameterized here. So that mailbox will work under the data type only. Okay. Next, these are the methods for mailbox, different types of methods. However, we seen in data types and arrays, the same mailbox methods. First one is a new. I already told, right? Whatever the instance we are creating in system Verilog, we create using the new method only. We already created dynamic array, associative array. Associative array, we didn't create it. Coming in future, whatever we are creating, semaphore, mailbox, in OOPS concept, if you want to create the constructor, class constructor, or object instance, everything we create using the new method only. Next, to put method. I already told, right? Put method means from generator to driver. If you want to put into the mailbox, there we use put method. Like monitor to mailbox, if you want to put the data, there we put the put method will be used. And get method, getting the data, retrieving the data. Peek method, also same as a get method only. And num method, number of messages it will be checking. And try put, try get, try peek. These all are non-blocking. We don't use non-blocking because why? What is the difference between blocking and non-blocking? In the sense, blocking will wait until the packet is available. Non-blocking will not wait until the packet is available. Suppose in the same example, here 16 number of transfers are doing, generating and sending to the mailbox. If you use try put, try get, try peek, those are all non-blocking. Okay, it doesn't wait until the packet is getting, whether it is getting the next packet or not. It immediately terminate once the driver sent to the, once the driver get the data. But if you use blocking, just a put get, it will wait for next packet to come. Okay, that is the difference. So you can read the statement here. Blocking means it will wait until packet available, whereas non-blocking means it doesn't wait. Suppose if you have a mailbox in that, you don't have any message. So blocking method will wait until a message will come in mailbox. On other hand, non-blocking will not wait for the same. Okay, so here are the examples.
Ma'am, I have a doubt.
Yeah, tell.
Yeah, so you are telling for non-blocking, it will not wait. So if there would be no any message in the mailbox, then how would it transfer?
If there it just wait for next transaction. Maybe for this time, present time, it may not have any messages. It will wait whether next transaction initiated or not to get until next transaction. It will be checking.
Okay.
Suppose if there are 4 transactions, so generator side, it will take some time to generate the randomization, random values to put into the mailbox, right? So in blocking, it just wait for some time, just for 10 seconds or 5 seconds. If in case it is not still getting any data, then automatically it will terminate the loop. Or else it will wait for some time and it is just checking. But in non-blocking, it doesn't wait. It just terminate if there is nothing data.
Okay. Got it.
Okay, so if you see here, this is what generator. In generator, we need to create the mailbox. 6th line, if you see here, 6th line, it is a parameterized mailbox, but that you can create normal one also. So if you see here, 2nd line, mailbox, my M, name of the mailbox. Okay, normally, if you are sending to driver to generator to driver, we use gen to drive based on those variables, like monitor to scoreboard, suppose, or monitor to driver to scoreboard, drive to scoreboard, drive to monitor, or monitor to scoreboard, like that we can create. So mailbox and so here mailbox like this all you can create. It's a parameterized and here it is a normal mailbox my M. After doing that, in generator class, if you see here 18th line, we are doing the randomization here. Gen to gen dot randomize. That means it will generate multiple number of values. Okay, and gen to dr is a mailbox name here. Here we have created already. Gen to dr is a mailbox name. Dot put method. That means we are putting what we are putting data to send. What is this data to send? The main transaction data. This data to send is the instance of class calci-trans. What is this calci-trans? This class. Within the class, we have created all the data right here, instances. So whatever the data we are randomizing for all these input variables, we need to put all these input variables to the mailbox. Okay. For that purpose, to access this class data, we need to create the object. Through the object only, we can access the class data. Okay. So that's why for this calci-trans, we are creating the object called data to send. Now, by using this data to send instance, or else we can call as an object, by using this name, we can access all these variables. Okay. These variables are nothing but input and output variables. Input variables, we do the randomization. That random data we need to put into that random data we did here, randomization. Okay. Now that data we need to put into the mailbox. Same here we are doing. Gen to drive is the mailbox name dot put. But what we are putting means data to send. That's what transaction data. Okay. Now this same data in the driver we need to get. Okay, so how we can get the data in a driver? See, this is what driver class, 7th line if you see, creating the mailbox again. Okay, now 44 line, gen to drive dot get of duv data. Here again created transaction name differently, but mostly we will create transaction names same only. But in this case, we created differently, but not a problem. So that data we are getting into the driver. After getting into the driver, what we need to do? Send to the DUT. So this is long. You will understand this in a interface concept. Okay, putting into the interface. Okay. So this is what the mailbox concept generated to driver. Like that monitor to scoreboard also same. See here in monitor 66th line. Monitor to scoreboard is the name of the mailbox. Fifth line, if you see here, monitor to scoreboard is the name of the mailbox. So put method, where we are putting into the mailbox what we are putting SB data, nothing but transaction data. Okay. Next, in the scoreboard, we need to get the data. So in scoreboard also created same mailbox, and fifteenth line, monitor to scoreboard dot get, what we are getting transaction data. Okay. So this is what the mailbox concept. Everyone understood clearly? Tomorrow we will discuss semaphore, events, and interface concept, so that interface will take 2 days time. We will start OOPS concept from next week, mostly from Friday or Monday, next Monday. Okay. Any doubts for today?
No, ma'am.
Others, everyone? Shweta, Kalyan, Aditi, Lahari, Manoj, Navin, Ranjit, Shubham, Sunny, and Vinita.
No, ma'am,
No.
clear.
Okay. So today I will
No,
share
ma'am, it's
the
clear.
Okay. So today I will share the assignment on queues and mailbox. So everyone practice, and I will share the recorded session also. Are you facing any problem again with recorded? I already shared in the group, but I will put all the codes at one page and I will share you. It takes some
Yeah,
time. Okay.
Tomorrow there will be no class.
No. You asked alternate days only, right? Do you
Yeah,
need
yeah. No, I thought in this week it will happen again. Training.
Fine. We have lot of time. Why we need to run? Just learn slowly.
Yeah, no,
Put
fine.
time into the assignments. Okay.
Yeah, fine, ma'am.
Okay, then thank you.